Welcome to Brain Vision.
Okay, this is question 28.16. We have a very long straight horizontal wire with a current such that 8.2 times 10 to the 18 electrons per second pass through any given point, and that's going from west to east. So we are looking for the magnitude and direction of the magnetic field at a point 4 centimeters or 0.04 meters directly above the wire. So the magnetic field from a long wire is shown here. And notice that the first thing we're going to need to do is find the current. So the current is just going to be the number of electrons passing through per second times the charge of the electrons. So we know that there are 8.2 times 10 to the 18 electrons going through per second. So we're going to want to multiply that by the charge of each individual electron, which is going to be 1.6 times 10 to the minus 19 coulombs. And when we plug that in, we find that the current in this case is 1.31 amps. So now we have our current. And looking at our original equation up here, we have all the other constants. So all we need to do here is plug in 1.31 to this, plug in 0.04 to this because we know the distance, and that's going to give us a magnetic field with magnitude 6.56 times 10 to the minus 6 Tesla. Now, we're told that these currents are moving from west to east, but remember that electrons have a negative charge, so this means that currents, as conventionally defined, is actually going from east to west. And so imagine pointing your thumb from east to west, so pointing left. To find the direction of the magnetic field, we want to curl our fingers over. So up above 4 centimeters above this wire, our fingers are going to be pointing into the page, which corresponds to a cardinal direction of north. So this magnetic field has magnitude 6.56 times 10 to the minus 6 Tesla, pointing north.